So again, the objective here is to compute the support reactions in this structure. It's composed by a single body, so there's no internal releases. And I have on the left side a pin support, which has two reactions, VA, if this is point A, and HA. And I'm going to assume VA is upwards and HA is to the right. On point B, I have a roller, so it means I only have one reaction, which is perpendicular to the base, perpendicular to this line here, VB. So I have a single body, I need three reactions, which I have, HA, VA, and VB, and I have three equations of equilibrium. Sum of horizontal forces, sum of vertical forces, sum of moments to any point. It's usually easier to choose a point where as many unknowns as possible go through. So VA and HA go through point A, HA and VB go through point B. So either point A or point B with good choices. Let's make it A. So I have three reactions and I have this distributed load here, which I will come back to soon enough. So horizontal forces, the only horizontal force is HA. If I use the usual referential, HA is positive, it's the only force, so it must be equal to 0. Vertical forces, I have VA, which is upwards, positive, VB, which is upwards and then positive, and I have this distributed force. So let's look a little bit more careful about this distributed force. So it's equivalent to 5 kilonewtons per meter, so it's not quite a force, it's a force per unit of length, and it's applied over a total of 11 meters. So the resultant of this force for reactions, this whole force is equivalent to 5 kilonewtons per meter times 11 meters, meaning 55 kilonewtons. And since this is a rectangle, it is applied at the middle of it. 5.5. So VA, VB, and the other vertical force is 5 kilonewtons per meter, which is vertical but downwards, so negative, and the resultant of this is 55. I get two unknowns, so I cannot solve this, so I have to go into the third equation and hope that helps me. So moments in A, I have HA, which goes through point A, so it doesn't cause any moment. VA, which also goes through point A, so causes no moment. VB, which causes a rotation like this, positive. So VB is positive, and it's 5 meters away from point A. So the lever arm is 5. And now I have the distributed load. It makes around point A, makes it rotate like this. So it's 55, which is the force, times the distance, and it is negative. The distance we see here is 5.5 meters from point A. So this is 5.5. This is equal to 0. Solving this, VB comes equal to 60.5 kilonewtons, and replacing here, I get VA equal to minus 5.5 kilonewtons, meaning that VB is positive, so it is upwards, like I assumed initially. VA is negative, meaning is actually downwards, unlike what I initially assumed.